My name is Gashteovski. I work as a senior research scientist at NEC Laboratories Europe in Heidelberg, Germany. I work mostly in artificial intelligence and natural language processing in particular. Or to be even more specific, I work with large language models, explainable AI, and evaluation topics. One of the greatest challenges with large language models today is the situation when they sometimes produce factually incorrect information, but they look like or they sound pretty plausible to a human. For this reason, one of the greatest challenges is to actually either mitigate these hallucinations or help people easily detect when or where the large language models generate factually incorrect information. At NEC Laboratories Europe, we developed the technology that we call the LLM Explainer. With this technology, a user asks a large language model some question, or it gives some task to a large language model, and then the large language model, of course, answers to this question or to this task by generating a text. And then our technology is trying to link the generated content from the large language model back to some original documents that were previously provided by the user. And with this, we help build more trustworthy AI systems because the users can now see for themselves where the information is coming from, and also it helps them assess whether it's factually correct or not in a very fast and efficient manner. The way we do this is through synthetic data generation. And to be more precise, what we do here is we use larger LLMs, so LLMs that have 70 billion parameters or more. We use them to generate some training data. And then with this training data, we fine-tune a smaller language model, so some model that has, for instance, 1 billion parameters. But the way we generate this data is different from how people typically do this. So what people typically would do is, okay, you have a question, you have some answer, then generate some links between the generated content and the provided context. This is the so-called discriminative way of labeling, and the current large language models that people typically use are actually generative models, which means that they're not really best suited for this sort of discriminative task, but they're more suited for generative tasks. So we went backwards with our solution. Basically, we provide some sort of sentences as seeds to the large language model, and then we ask to generate the question. So we already have the alignments because of this. And the large language model is tasked with generating the question. And this is what they were typically trained to do. They were trained to generate text. So that's why we leverage this advantage to generate more high quality data, which then was used to train smaller language models to fine-tune them on this particular task, which provided the best results. And what is more important even is that this technology paves the way for building AI systems that foster trustworthiness to people and also enables us to build more reliable AI systems. This technology can in principle be used in many different domains. So it's not bound by a particular domain. As long as you have text and human language, then you can use it. One example would be the way medical doctors work. So they have to write a lot of reports or even their own doctor notes when they work with a patient. And so this consumes a lot of their time, actually. What they can do instead is they can ask a large language model to generate the report for them. But because they have to be sure that the report does not contain factually incorrect information, they can use our LLM Explainer to verify whether the generated text was actually correct or not, and to correct it as they go. Another use case would be when executives, for example, generate reports for whatever, they can use large language models to do this automatically. But again, they have to be certain that the generated content is actually factually correct. So they can use the explainer to actually verify whether the generated information is correct. The next big challenges in this direction are probably related to the way the large language models work. And so I would say that probably the next big thing that should happen in this direction would be to truly understand why the large language models produce the answers that they do when they're factually incorrect, and to find ways to automatically correct it before it even reaches the user. And so for this, I would say maybe something along the lines of discovering causal relationships of the entire neural architecture would be something that I would be personally curious to see.